everyone. Now we're going to pick up with part B-2 of this chemistry Regents. This is the start of the free response section with questions number 51 all the way to number 65. So number 51 to 53 is the first group of questions. Here they're going to talk about halogens. And 51 asks, state the trend in electronegativity for the halogens as these elements are considered in order of increasing atomic number. So I'm going to pull out the periodic table. Alright, so group 17 has all the halogens. So we're going to look at the vertical column with the number 17, and we're going to take a look at each of these halogens over here. So we need to talk about electronegativity. And my thing for electronegativity and trends in general is to find the element with the highest or lowest value and use them as reference point. Because the further away you go from the highest electronegativity element, the less you get, the lower the electronegativity. So what do I mean when I say that? Okay. Fluorine happens to have the highest electronegativity value, and that's a 4.0. The further away you go from fluorine, either to the left or down, the further away you go, the lower from 4 you get. So the further away from 4 you get. So that means chlorine, bromine, and iodine will have lower electronegativity values. So chlorine is the next is the second highest, bromine will be third highest, and iodine will be the fourth highest in that group. So as you go in increasing atomic number, that means 9, 17, 35, 53, going down, it's going to decrease. So that's our trend. You're going to use fluorine as a reference point. It's a good one to remember. All right, identify the type of chemical bond that forms when potassium reacts with bromine to form a salt. Okay, so potassium is K, and then bromine is Br. Together, well, they're ions, will make KBr, potassium bromide. Okay, so when you combine a metal with a nonmetal, that type of bond is ionic. They usually make salts. Salts are typically ionic compounds. All right, next we're going to use table F, and we have to identify one ion that reacts with iodide ions to form an insoluble compound. So we got to pull that up in a bit. All right, so we're going to be focusing on the halides group in the solubility table. Table F. Oh, that's the wrong color. Okay, halides. So we're looking for one that forms an insoluble compound. Halides in general typically form soluble compounds, but here are the exceptions to make them insoluble. So it's got to be Ag+, Pb+, or Hg2+. Okay, silver, lead, or mercury. So any one of those three could be valid choices for your answer. So I'm going to write down Ag+, but acceptable answers would also be lead 2+ or mercury 2+. All right, the next group of questions are 54 to 57. Number 54 says, identify the element that has an atomic nuclei represented by nucleus 1. Okay, nucleus 1 is right here. We have to look at our key. What identifies the element? It's the number of protons, okay? So you have to look up the number of protons. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we're looking for the element that has 9 protons, an atomic number of 9. Okay. And that would be element fluorine. Okay, fluorine is our answer. Number 55, determine the mass number of the nuclide represented by nucleus 2. So mass number is the sum of protons and neutrons. So we had to count up all of these guys here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So there's a mass number of 18. And that's all you need to write. Number 56. Explain why nucleus 2 and nucleus 4 represent the nuclei of two different isotopes of the same element. All right, so Key thing when you're looking at something with the same element, they have to have the same number of protons. So we had to look at nucleus 2 and nucleus 4 and see if they have the same number. So you have 1, 2, 3, 4, 5, 6, 7, 8. And then over here, 1, 2, 3, 4, 5, 6, 7, 8. So they do have the same number of protons. Now, in terms of isotopes, they have to have different number of neutrons then of the same element. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here we have 10 neutrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Here's 11. So they have same number of protons. That's important to state. And then different number of neutrons. All right, and number 57, identify the nucleus above that is found in an atom that has a stable valence electron configuration. All right, stable valence electron configuration refers to noble gases. They are in group 18. So we got to find the nucleus of something that has the same number of protons as a stable valence electron configuration or noble gas, somewhere in group 18. So we already found that nucleus 1 has 9 protons, that's fluorine. Nucleus 2 and nucleus 4 have 8 protons each, that's oxygen. Now, nucleus 3, let's just verify. It might be that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Number 10, that's neon for sure. 10 protons, so it's definitely nucleus 3 for neon. Okay, number 50 to number 60 is for this group. And here we have an equation of hydrogen gas and oxygen gas forming H2O, water vapor. And number 58 is asking this change in energy that occurs to break the bonds. Oops. So we're breaking bonds in hydrogen molecules. So in order to break bonds, you have to absorb energy. So you could either say absorbs energy or increase in energy. So breaking, absorb, forming is release. Okay, number 59, we have to draw the Lewis electron dot diagram for a water molecule. Okay, so water is H2O. We start with oxygen in the center, single bonds to hydrogen. And we got to make sure that oxygen has a stable configuration with the octet. Right there, 2 lone pairs to complete the octet. And that is your Lewis electron dot diagram for water. You don't have to do it in this bent configuration. You could do it linear, but just to be very precise, because you never know who's grading you, I highly suggest you put in the bent shape, because that's how water molecules are actually formed. Okay, number 60. Compare the strength of attraction. So when we say that, we mean the electronegativity for electrons by a hydrogen atom to the strength of attraction for electrons by an oxygen atom within a water molecule. So hydrogen and oxygen, we're comparing them. Oxygen has an electronegativity of 3.4, and hydrogen has an electronegativity of 2.2. Okay, and this you could look up on table S. So what you're going to write is that oxygen has stronger attraction for electrons. Okay. All right, number 61 to 63. We had to identify the element in stearic acid. Wow, that was a struggle. That makes it an organic compound. So any compound that has carbon will automatically deem organic. So carbon. Number 62, to state the direction of heat transfer between the test tube and the water. Okay, so heat travels from high to low in terms of temperature. So test tube has 22, the water is 98. So here in this case the water is high and the test tube is low. So it's going to go from water to test tube. Okay, number 63, we have to show a numerical setup. I'm going to actually change the page a bit just to shift things up. Okay, we're resuming with number 63. We're going to show the numerical setup for calculating the amount of thermal energy change for the water in the beaker. Actually, I need some information. Okay, good, right here. So we're looking for thermal energy change. That's going to be a change in temperature. And we're involving a change in temperature here for the water in the beaker. All right, so we're going to use this equation, which is on the reference table T. We're solving for Q, which is the amount of heat energy, the thermal energy. The mass of the water is 320 grams. C, because we had to look that up on table B for the constants, that is 4.18 for water, and the change in temperature will be from 98 to 74. So that would be your numerical setup. You just need to show this setup following the formula and you get the 1 point. Okay. Numbers 64 and 65 are given below. Here we have a nuclear reaction. We have to identify the decay mode of hydrogen 3. So this means we need to pull out the reference table. Alright, so hydrogen 3 on table N has a decay mode of a beta particle. So you could say beta or write the symbol for beta. Okay. Number 65, explain why the equation represents a transmutation. So by definition, transmutation involves one element changing to another. So that would be your answer in straight, simple terms. The simpler you write, the better. And that's it for part B1. The rest of the questions from 66 to 85 will be for part C.